I am going to be doing a simple demonstration today to show how polarization can be transmitted on ordinary longitudinal waves. Now, I am going to make the outrageous claim that light is not an electromagnetic phenomenon, whereas everyone has seen they have a picture of a diagram of crossing electric, and then there's a magnetic field. So light is supposed to be an alternating electric and magnetic field. Of course, the only problem with that is that no one has ever actually been able to measure the electric field being generated out of, say, a transmitting antenna to a receiving antenna. Nor anyone been able to measure, say, the magnetic field by, say, putting something like a compass, and then, theoretically you should be able to observe the compass alternating from north to south, but there's no such experiment. So you can check me on that. You can search all you want on the internet, and you'll never find an experiment that does that. And one clue is that you can't measure the magnetic field in volts, okay? You've got any experiment which is returning the results in volts, you're not measuring the magnetic field. It must be measured in Tesla, and it must tell you the exact north-south orientation, okay? But you can check me on that, but I'll assure you there is no such experiment supporting that. So instead, I support the idea that light waves are just like sound waves, or like waves in water. And so I have set up this ripple tank here because the main objection for why light cannot be just like air or water waves is going, well, what about the polarization? How polarization can't be done on a longitudinal wave, right? No, wrong. I'm going to demonstrate that polarization can be done in longitudinal materials. It's just that the polarization is, not done in like a single plane, like a rope through a picket fence. That's a very naive picture of polarization. So I'm going to demonstrate that in the ripple tank. Okay, so first of all, what do actual waves look like from, say, a rod antenna? So pretend that this is a metal rod antenna. Okay, so if space works just like the water, then it's going to vibrate. And what it's going to do is it's going to set across these waves, which are actually in the shape of the antenna. You see the shape is a long vertical element, and the waves that go across are exactly that same shape. Okay, so that's point one. So it's not like the rod is like moving up and down and forcing something in the transverse direction. Well, all we have is this large wave fronts moving across. Now, what is the effect if we had a receiving antenna? So this is receiving antenna. So ripple tanks always just stop right there at the wave thing, but let's put a receiving antenna there. And we start our ripples here, and we can see that the receiving antenna is getting hit by this large wave front, like all at once pretty much, right? So the wave comes around and it hits the receiving antenna all at once. So what is polarization? So what polarization really means is that if you change the orientation of the receiver, then it reduces the reception. So, for example, we have these two, they're both oriented in the same direction, but if I were to turn this 90 degrees, then they would be at a 90-degree orientation, and we would find that in real radio waves, that if this was a real transmitter, this is a real receiver, we would find this is at a minimum reception. You turn it the same way, you get maximum reception. You turn it this way, you get minimum reception. So why would that be? So if we just stuck this back into our ripple tank here, it should be quite obvious that if this receiving antenna is at this angle to this transmitter, then the only part of the wave that it's going to intercept is just this tiny little cross section of it, versus, put it this way, you get the entire wave hitting it all at once. But another way to do it is just turn our receiving antenna rod this way, and then once again you can see that when the waves come through, it's only intercepting a very tiny amount of the wave energy, total wave energy, that's being generated here by my generator. So that clearly demonstrates a polarization activity. And this is being done with ordinary water using longitudinal waves. Now, as a caveat, it could be said that the waves being generated in a ripple tank are, transverse, because we do have the ripples are a little bit higher. Although it's still perfectly analogous to it being a compression wave, as in the little humps. If I were to animate this on a computer, it would look exactly the same way. So there's no difference as far as this being an analogy to longitudinal waves. So that is my demonstration. I hope that helps convince you that polarization information can be encoded in regular longitudinal waves, but it's encoded on what you see is the wave front. It's a whole bunch of like the water here, all moving at the same time, but you can see the polarization angle. You can see it in the wave there. It's that entire wave front which encodes the polarization, and should not be thought of as anything like a rope through a picket fence, which is an extremely naive way of thinking how radio waves might work.